My name is Amin, and I'm presenting the non-uniform processing method for large data sets, large photogrammetry data sets. And my co-authors are Ms. Atiyeh Ghorbani and Dr. Andrea Jalandoni. And first of all, why use the non-uniform processing method? Okay. Um, it gives us a cost-effective solution for processing large data sets, which is most of the time a challenging part of processing, large data sets. Not everyone has access to high performance and expensive processing systems. So this would be a cost-effective solution for processing these large data sets, especially when dealing with large building in cultural heritage, which where the 3D models are generally heavy and large. And secondly, it helps reduce output file size without loss of quality, which is really important because photogrammetry models output models are generally large, and there are some issues with copying, transferring, storing, saving in hard drives, and or presenting these models online. And more importantly, these models are not so popular among the other users of 3D models, like game developers, like filmmakers, animators, 3D printers, VR, AR platform users, because of large size. So an optimized 3D model and reduced file size would help make these models more efficient to other users. And why not use these non-uniform models? Yes, it takes more time processing because of its some additional and some additional steps during the processing procedure. If you pay attention to this image, you can see a historical building full of astonishing paintings on flat surfaces and some 3D decoration, plasterings, and a white beautiful sculpture in the front. And as you can see, paintings are generally painted on two-dimensional flat surfaces, but before that, let's say something. 3D models generally are made of two parts. One part is mesh, which represents and reconstructs the physical shapes of the building, of objects, and mesh is made of triangles. And the other one is texture, which is made of millions of tiny pixels, which represents the visual colors and texture of surfaces. So if you pay attention to these decoration and plastering, you literally see no texture on them. Only, for example, if you look at this sculpture, you see only a white color and no texture. So I came up with this question, with these two questions. That first of all, why spend so many tiny pixels to reconstruct a texture file for a textureless surface, like this sculpture or this plastering or this decoration, while we can generate a texture with less pixels and larger pixels, because less or more, most of the pixels of this sculpture are similar and all of them are white. So why spend megabytes on saving unuseful useless pixels, and on the other side, why spend millions of triangles to reconstruct a fully flat surface while you can reconstruct it with fewer triangles, like 10 triangles, like 50 or 1,000 triangles instead of uh, millions of them. If you pay attention to these paintings, for example, this one, it's a square flat surface that you can reconstruct the shape of it by only even two triangles. So why spend millions of them? And you know that photogrammetry software generally processes millions of triangles in automated procedures. So me and my collaborators decided to work on a method to optimize models. And I'm going to read this. Non-uniform processing method allows optimized data generation. Each part of the model, whether a point cloud, mesh, or texture, receives exactly the number of points, triangle, or pixel it needs, and no more. So optimized 3D models are more efficient and practical for use in fields such as gaming, cinema, 3D printing, etc. And this is our case study, the Shams-ol-Emareh building in Golestan Palace, a UNESCO World Heritage Site in Tehran, Iran. And in the right side, you see a picture of the building, and the left side is a picture of the 3D model of the exterior facades of Shams-ol-Emareh building. And this is the interior rooms spaces, which are 56 spaces, including rooms, including staircases, bathrooms, the corridors, etc. And you can see all the images captured in each room in blue. And we captured the facades using a drone and a DSLR digital camera, and the data collection took around 43 days, including surveying, measuring control points and targets, and capturing images, which around 30,000 images were captured during these 43 days, and all processed using the AGI soft metashape. And this is the flow chart of the non-uniform processing method. It might seem a little bit complicated, but the idea is so simple. In photogrammetry, we have different steps, various steps to process our models to get to the final model. It starts with alignment, then we generate point cloud, we generate meshes and textures, and then we create 3D tile model if needed. And the idea of non-uniform processing method is to split data into smaller fragments in each step, do your edits, do your processings, and do your decimations if needed, and then join those smaller fragments together and bring the data to the next level. For example, you create a 3D model, bring it into a smaller model, bring it into smaller models, you decimate surfaces, decimate triangles, and do your edits and do your processes, and join them together and bring it to the next level, which is next step, which is generating texture. And as you can see in this picture, this is a point cloud. The first step of generating point cloud is to, generate the point cloud with the smaller parts using the region box by resizing it And as you can see, different region box has been used to generate the point cloud part by part. Some parts were more important physically, so they get a higher quality while processing, and some less important part gets a lower quality of processing. And then we join them together and get the whole point cloud of the room. For the second time, we split it into fragments, and this time not cubic, but selective, using the selection options of AGI soft metashape. And as you can see in this picture, in the right side, the most physical important parts like the ceiling and walls has been extracted from the main body and reduced in density, but this part gets the least reduction because it's the most important, and the ratio of reduction is 1.7 to 1. And in numbers, you can see 105 million points gets to around 60 million points. And on the left side, you can see that the least important part, which is the flat floor, gets the maximum reduction, and the ratio is 65 to 1, and it means that 3 million points have been reduced into only 50,000 points. And after each part has been extracted and reduced, then they join together and once again generate the whole united point cloud of the room. And as you can see in this picture, the density of points are non-uniform, and eventually we have the non-uniform point cloud of the room. This is the same for meshes, and as you can see in this picture, we have a mesh with flat surfaces in sides and in the ceiling, and these parts have got the maximum reduction. You can see fewer triangles and larger, but no reduction in the detail of the brick lines like door and wall boundaries, and frontiers between floor tiles is evident. Okay. And this is another example of the 3D mesh and triangles of a large room, which is full of flat surfaces, so it gets reduced by a large ratio. And here we have the non-uniform texture. As you can see in this picture, the textureless and unimportant surface, which is a white wall, has the largest pixel size, which is 1.8 centimeters. And just next to that, some important surface gets the maximum resolution and the smallest pixels, which is 0.249 millimeters. And just like that, another part gets 0.4 millimeters, and this textureless mirror gets 1.8 centimeters. And eventually we have the non-uniform texture of the whole room, which seems quiet, natural, and realistic. And after all the rooms are processed and reconstructed perfectly, they get located in their accurate coordinates with the help of targets and control points. And you can see that these rooms are set next to each other. And this is the left side is the 3D model of the exterior facades. And here we have a comparison with the non-uniform mesh model versus the normal and the traditional mesh model. And you can see that all triangles and density of triangles are less or more the same in different parts of this room in the traditional model, and in the non-uniform model, flatter surfaces got larger and fewer triangles, which takes less data and megabytes to store. And this is a comparison of the quality between traditional and non-uniform processing method. We don't claim that this method always improves the quality of model, but because of some anticipated edits and freedom of edits and control that this method gives to the user, sometimes it helps improve the quality of model, especially while reducing noise and deleting and omitting noises. And finally, we have numbers. As you can see, the number of point clouds, the number of points in point clouds has been reduced from 268 millions into only 27.8 millions. And triangles as well, 38 million triangles has been reduced into almost 1 million. And about the output file size, you can see that LAS and TXT point clouds has been reduced perfectly, and the FBX and OBJ mesh models also have been reduced perfectly. And you can see these numbers and percentages in this table. Number of points have been reduced to 89%. Number of triangles have been reduced for 97.38%. The textures, the point clouds in text format and point clouds in LAS format also have been reduced into around 90%, and output mesh files in OBJ and FBX formats have been reduced into around 97%. Thank you very much.